All right, so this numerical is again from non-uniform circular motion. Now it says that if generally if you discuss the concept, you have a situation where you have circular motion and the velocity and the centripetal force or acceleration are in, theta is equal to 90 degrees. Okay, so this is the situation of uniform circular motion. And then you have non-uniform circular motion, where the body not only has a centripetal, which is the radial acceleration. So this is called as radial acceleration. And the velocity here, the magnitude of velocity is same throughout. Okay, the velocity does not change. If it is 5 meter per second here, it becomes 5 meter per second here, which is the magnitude. But directionally, the velocity does undergo a change. So if you were to, talk about non-uniform circular motion, okay, which is this, not only the velocity, magnitude keeps on changing. So the direction definitely changes, just like, the uniform circular motion. The direction changes for sure but the second thing that happens here is the fact that you have change in magnitude also. So if the velocity here is 5 meter per second, the velocity here becomes 6 meter per second. So the velocity change magnitude happens and the direction also changes. So when the magnitude of velocity changes, you have one more acceleration that comes into picture, which is the tangential acceleration. So these bodies, you have the situation where the body not only has a centripetal acceleration, but also has tangential acceleration. Okay, so the acceleration is tangential. So this is AT. Okay, AT. That is what it is. And I'll just rub this off. I think let me just rub this. But the point is, you should be able to see that what we are discussing here is essentially two types of. So you have this AT and you have this as the radial acceleration. Okay, so this is your radial acceleration and that's your AT. Now if you see, this body will have two accelerations acting on it. So one is the radial acceleration and the other is the tangential acceleration, both acting at an angle. And you will get, because of this centripetal acceleration, which is this, and you can show this as a centripetal and a tangential. Okay, so a centripetal is towards the center of the circle and tangential is because of change in magnitude of velocity. So the actual magnitude of velocity changes here. So if we complete the parallelogram, what you get is this, and you can see the resultant acceleration is coming out to be this. So this your resultant is AT square plus A radial square. So which means your net acceleration, is somewhere here. If I just draw a parallel analogy, and you can see the velocity, which is in this direction, has an instantaneous acceleration, which is the resultant of the centripetal and the tangential. So this is your A resultant. And your A resultant now makes an angle which is between 90 and 0. So be careful. Uniform circular motion, which we have covered in detail, has the angle between velocity and centripetal acceleration to be 90 degrees. And non-uniform circular motion, the angle reduces because you have another component called as A tangential, and this is your A radial. Okay, the A tangential is because of actual change in magnitude of velocity. A radial is because of change in direction of velocity. So I hope this clarifies. We have not done uniform circular motion much in detail. We have done some aspects of the circular motion, but a lot will be done once we are through with, and before we commence the rotational motion. At that point of time, you will see all those terminologies of alpha and stuff like that. But non-uniform motion we have done, but not to a large depth. So I hope this helps. There is no need to be disheartened because non-uniform circular motion will come, and at right time you will learn the concepts. Thank you very much.